All right, here we go. Wednesday, February 3rd, National Carrot Cake Day. The day the music died. This probably has something to do with Buddy Holly. Missing Persons Day, Women's Physician Day, and Girls and Women's in Sports Day. Remember to work hard and be nice. Today we're going to go over some triangle inequality stuff. So we have two goals. Goal number 1, is it even a triangle? Goal number 2, how do the interior angles relate to their opposite sides? So here we go. Goal number 1, is it even a triangle? So hopefully you can see, yes, this is a triangle. And what we're going to do is we're going to mess with these sides a little bit. And we're going to see if we can make a triangle based on random sides. So 10 is going to stay consistent, and then I'm going to change these distances right here. So I'm actually going to start with, let's start with 4 and 6. So if I start with 4 and 6, is it a triangle? Can I make these dots get really, really close to each other, making a triangle? So I can almost make them a triangle. But if you look at it, it doesn't actually make a triangle. It makes a line. And the reason why is because the two sides added together, 6 plus 4, is the third side. And when that happens, the third side and the second side just fold on top of that red side. If we want to make it a triangle, what we have to do is we have to make one of these bigger, or maybe both bigger. Watch this. I'll make it 5 and 6. So now if I want the yellow beads to overlap each other, okay, now they can elevate a little bit. So you'll notice 5 plus 6 is 11. 11 is bigger than this other side of 10. Therefore, it's going to form a nice triangle for us. Let's see, make it a triangle, make it a triangle. There you go, cool. What if we make it 8 and 5? Well, 8 and 5, that's probably going to make a triangle too. Watch this, I can bend this down. 8 plus 5 is 13, and 13 is bigger than 10. So when these two sides add up to a number bigger than 10, or bigger than the third side, you're going to make a triangle. Let me show you a really sad looking triangle. Something like this. So notice 3 plus 4 is going to be way less than 10. I cannot make these touch each other. So 3 plus 4 is going to be 7. 7's not bigger than 10. So this is not going to be a triangle. So if you know two sides, let's say I know 5 is the side of a triangle, and I know that 6 is another side of the triangle. The third side has to be on a specific range between two numbers. It can't be too big, because if it's too big, you get something that looks like this. And if it's too small, you'll also get something that kind of looks like this. Right? So there's kind of a sweet spot, like a little Goldilocks spot that this third side has to be in. And you can find that by taking the two sides that you're given, adding them together. 6 plus 5 is 11. And 6 minus 5 is 1. So as long as your third side, we'll call it side AB for me, is between 1 and 11, then you're in good shape. Then you know that you're going to have a triangle. If it equals 1, we discovered that it's going to be, your shape is going to be a line. If it equals 11, we discovered that it's also going to be a line, which is not a triangle. So let me ask you, is this a triangle? Let's say I had 5, 12, and 18. Is that a triangle? So the first thing you need to do is pick two sides that you want to deal with. I'm going to pick 5 and 12. And you need to figure out if the third side fits between those two sides. So in order to figure out how big the third side can be, you're going to do 5 plus 12, which is 17. And in order to figure out how small the third side can be before it's not a triangle anymore, you can do 12 minus 5, which is going to be 7. So now, is 18 between 7 and 17? I would say no. So this is not a triangle. Triangle inequality. Let's do another one. Example 2. Let's go 5, 7, and 5. right? So hopefully you're like, well, we do know that two sides are congruent. So if it is a triangle, it's probably going to be an isosceles triangle. Let's figure out if these three sides form a triangle. So again, you exclude a side. I'm going to exclude this side. You can exclude whichever side you want to. And I'm going to take these two numbers and add them together, 5 plus 7, to figure out how big the third side can be. And I'm going to take those two sides, the same two sides, to subtract them. 7 minus 5 to figure out how small the third side can be. 7 minus 5 is 2. 7 plus 5 is 12. Is 5 between 2 and 12? Yes, it is. So therefore, this is a triangle. There you go. There's goal number 1. We're going to bring it all together in a second. Goal number 2, the biggest angle is always going to be opposite the biggest side. And the smallest angle is going to be opposite the smallest side. And that makes sense. If you think about like an angle like this, like a nice right triangle, the hypotenuse will always be the biggest side because it is opposite the biggest angle. And then if I make that angle even bigger, let's say I make it 120 degrees, all you're going to be doing is stretching out this third side, or this C. So as the angle gets bigger, this way, the third side is going to grow. And as it gets smaller, it's going to shrink down. So the biggest angle is always going to be opposite the biggest side. So for example, if I had something like this, if I knew I had a 30, 60, 90 triangle, we'll call this A, B, C. And we'll say A is 60 degrees, B is 90 degrees, and C is 30 degrees. And I'm going to go biggest side, well, I'll go smallest to biggest. Right, so because I know the smallest angle is angle C, I can get that the side opposite angle C is going to be the smallest side. So AB is going to be the smallest side. Followed by the next biggest angle is A. So the side across from A is BC. BC is going to be my next smallest side. And then my biggest side is going to be the hypotenuse, which is opposite the 90-degree angle, which is going to be AC. So we don't know how big they are. All we know is their relative size. AB, we don't know if it's 8 inches or 10 inches or 30 feet or a mile, but we do know that it's smaller than BC, which is smaller than AC. And we know that none of these sides are congruent because none of these angles are congruent. Let's do one more. I'll give you sides this time. So let's say I have a 5. I'm not going to draw it to scale. Let's get crazy here. Let's say ABC, 5. We'll go 7, and we'll go 10. So the first thing that you should technically do is you should technically make sure that it's a triangle in the first place. Because if it's not even a triangle, then well, maybe, and some of you are like, of course it's a triangle. Look, you can see it. Well, this picture doesn't necessarily mean this is what's going on. So let's go ahead and let's make sure it's a triangle. I'm going to pick two sides. I'm going to pick 5 and 10. So add them together. 5 plus 10 is going to be 15. And then 5 minus 10, or 10 minus 5, is going to be 5. So is your third side of 7 between 15 and 5? It is. So therefore, it's a triangle. And because it's a triangle, we can get the smallest. Let's go smallest side again. Actually, this time we'll go smallest angle to biggest angle. So the smallest angle here is going to be, well, 5 is the smallest side, which is AB, and it's across from this angle, which is C. So angle C is going to be the smallest angle. Followed by 7's my next biggest side. B is opposite 7, so B is my next biggest angle. And then finally, A is going to be my biggest angle. There you go. So takeaways. In order to be a triangle, you have to satisfy this right here. This is called the triangle inequality. You pick any side you want to. The third side has to be between the sum of the other two and the difference of the other two. If it is, then it's a triangle. If it's not, then it's not a triangle. And then finally, the second thing that we did is we figured out that the biggest angle is always across from the biggest side. And the smallest angle is always opposite the smallest side. Okay, cool. I got a little class kick for you. Check that out. We'll see you soon. Peace.